Hello, everyone. On behalf of Web Solutions, I would like to welcome you to our webinar, Introduction to Microservices Architecture. Before we begin, I would like to make sure that you can hear me. There is audio and you can see my slides. If you can send me a chat, that would be very nice. Thank you very much, Adam. My name is Mikhail Vladimirov. I'm the Director of Curriculum Architecture. Guys, thank you very much. It looks like we are all good to go. Web Solutions is a consulting and training company based in Toronto. And this particular talk or webinar is based on the materials that we have prepared in this area, Microservices Architecture. It's packed with material and labs. And in this talk, we just touch on more important parts of this course. So we will discuss problems with monolith applications, the quick introduction to microservices architecture, commonly used patterns. Probably that's what most of you are after, because everyone understands what microservices are. But still, we need to contrast so that we can really get the message home, why we need it. At the same time, I don't want to follow the traditional kind of monolith thrashing type of talk. Monoliths needs to be broken up. We need to totally migrate into the microservices-based architecture. We need to, I guess, dispense with the past and just march on forward ahead, whatever that means. Monolith applications still relevant, particularly in enterprise space, where high performance, real-time quality of service are critical. You need to have systems which would support transactions where you would like to have a very narrow or very kind of a small surface of security exposure. And it's okay to have tight coupling between systems. There are definitely architectural patterns to alleviate some of the problems of enhancing system, to maintain the system, but still they're relevant. And I believe there would be a message in one of the slides to really making you think that you have to ask yourself several times, do we really need to go this way, to go with microservices architecture? So I don't want to give you a specific recipe. It depends on the problem domains that we are working in and the type of applications that we have. And so it's up to you to decide, but I guess I will present as many options as possible for you to decide. Okay, so those were the advantages or arguments in favor of using monolithic applications. Disadvantages are quite obvious. In most cases, we have very large code base, which would create a problem for developers to learn, particularly when you onboard new developers and you just dump those developers in that pool of code and let them and see if they would swim or if they sink. And they get deployed as some sort of archive. I'm coming from Java side of things, and I've been working on online banking applications. I know firsthand what is involved. And usually, if you have problem with deployment of an ER file or WAR file or multiple WAR files, essentially you're doomed. You have to pull out, roll back your release and start troubleshooting as to what went wrong. Tight coupling of components of monolith, difficult to evolve, maintain, and test. Essentially, you have vendor lock-in situations. If you have adopted a particular application server and a suite of products, backend system and messaging system and application server, you have a kind of a very holistic solution, which is good, but it costs money. It might cost you arm and leg. So what can be gained if you go the way you take this path of breaking up the monoliths? The ultimate goals are quite numerous. First, you would be able to achieve the scalability. Scalability is very sought after property because that's the way for you to elastically react to an increase in traffic in demand for your services. You can build through that scalable solutions fault tolerant systems because you can always provision service on demand if you have that scalability built in place, and you can scale out your solution with demand as your demand grows, or to replace a failed service. It's easier, much easier to evolve services at a service level or at the tier level, whether it's the business logic or if it's the front end. You can test in isolation of those services, which actually promotes that test-driven development. Domain-driven design, a very popular kind of idea, and for any reason, people just want to mention Eric Evans' bounded context and ubiquitous language and all that kind of thing. And I'm will be doing the same in this presentation. More efficient dev teams, you will have smaller teams, particularly if you adopt that front end to back end type of micro UI type of pattern, which we're going to talk about shortly. And more important from the business point of view, you have that business capability supported by a number of products. So essentially, you, instead of project-oriented development, you embark on the road of product-oriented dev model. If you're not familiar with this concept, just take my word that this is really a possibility. And you can instill that sense of ownership where your people would be responsible for a particular service, and it would be very difficult to start finger pointing as to what's actually happened. With monolith application, if something goes wrong, there would be lots of finger pointing during troubleshooting or during the post-mortem. So that product-oriented model really helps to resolve many things before they become really toxic. And the Internet of Things is becoming a reality. You essentially can now combine and build some sort of a hybrid cloud on-premise type of applications. And a very popular, I guess, title for that type of activity for breaking up monoliths is application architecture modernization. It happens every so often, kind of a cycle. Every 5, maybe 7 years, there is another kind of a demand for modernizing your application, whether it was SOAP or whether it was a client server, whatever the case might be. And now people are moving towards adopting microservices architecture, which is the topic of our discussion. So what about SOA, service-oriented architecture? All the principles that have been proclaimed are still true, and microservices in most of the cases just kind of piggybacking those good ideas of kind of a great future and great performance and everything. But the problem with SOA was the technical side. First, lots of prescriptive technologies, UDDI, you just name it, SOAP, WS star technologies have become really kind of a drag on your design and development. And it didn't contain the proliferation of monoliths. Essentially, you ended up having lots of monolithic applications which were talking to each other using SOAP or any other protocols. And now the overall movement is towards distributed application design using microservices. And one of the, I guess, argument in favor of doing this is that people are kind of started looking at the cloud as one of the deployment options. And monolith applications are not so good. They don't lend themselves to be ported to the cloud quite easily. right? There are a number of considerations for that. And overall migration strategy has just this multifaceted kind of orientation. It has multiple focuses, and generally that's where things are moving. So what are the challenges? The biggest challenge is to transform the conversation between services, right? It's not enough to just take those components which were part of that war file, which were deployed in on the same contiguous heap, talking to each other at the level of in-process communication at microservices at microsecond level. And now the straightforward conversion of those interactions to using some sort of RPC-based calls. It may be TCP IP, or it might be gRPC, or any other modern ways of communications, or the regular RESTful calls might have a negative impact. Overall, you are kind of going to see like at least 3 orders of magnitude slower communication. So from that microsecond type of latencies, you would go up to a millisecond time range, even though networking now with the gigabit Ethernet can give you a very nice kind of bandwidth and throughput, but still you're losing compared to in-process calls. So microservices architecture essentially SOA. So for all intents and purposes, if you really look at it, but it takes into consideration lots of technical details, right? So services that are being used have that very specific kind of micro focus. And micro, it's about not so much the size of the footprint of the service as it is like a focus. It's sharp, and you can think about it as kind of a microscope. You take a microscope and you kind of look at your service, the boundaries, how you can define what actually that service is supposed to do. So that's the micro. I guess some folks coming up with those terms like big data and what's not microservices, and they're fuzzy, no SQL. But I guess we need some sort of like use so that we can start talking intelligently about a particular thing, right? But microservices are the answer to some of the problems with the original SOA philosophy. Actually, philosophy not supported on the technical side, right? So microservice architecture, really the success of those solutions predicated on the efficient operational life cycles of microservices, whether it's deployment, managing all the versions, maintenance, and what's not. But at the same time, again, as I said earlier, don't be carried away with that hype, and sometimes just people follow with the kind of with the crowd, and in some cases probably you need to take a longer look. And some people who have already tried that to go with microservices, and they just give you a word of caution. Microservices might not be good to really support very complex solutions where like transaction security and other enterprise grade quality of service are absolutely critical. Microservices themselves, in order to be successful, they have to force on you to do lots of things to make them really work as intended. So lots of that accidental complexity, which is not related to your essential complexity, where you're solving some business problems. So that's where you really need to think about and find that kind of good balance. And overall, if you have started using microservices architecture, microservices, don't discard your existing kind of practices for creating monolithic applications. It's okay. It's like NoSQL, when they come on board, it doesn't mean the end of the world of the relational databases. They would peacefully coexist, right? It's just a matter of different use cases, different solution architecture. that you might need. The overall cultural shift is required, right? The cultural shift in terms of DevOps practices and the way you think about you create applications. By the way, I would welcome your questions. Please put your question in the questions pane. I will keep my eye on it. Chat is quite chatty. I won't be able to maintain both. So please put your question as I see a question coming in. I'll try to take care of it if I feel that it would help with my narrative, or I will put it off until the end of my presentation, where we will have a Q&A. Okay, so this webinar is scheduled for about 1 hour, so let's see how it goes. I mentioned that you can help your monolith by using some of the existing techniques, patterns, and approaches. For example, layered architecture and separation of responsibilities, creating very well-defined cross-cutting concerns using aspect-oriented programming. So all those things are already there for you. And you can create quite loosely coupled, very good design for monolith applications, right? So it's not kind of derogatory term to name a particular application. If it's well designed using I don't know, dependency injection, particularly with JEE, or as it used to be J2EE. Now you have a way in the latest JEE specs, like 6 and 7, all those things, context and dependency injection is part of the framework. So whatever Spring promised with Rod Johnson, JE without J2E application servers is a reality. So if you adopt those things, first you'll do yourself a big favor, and at the same time you would be able to go with that transformation, that modernization type of activities much easier, because it will be much more easier to break up the monolith, quote unquote. So a microservice is essentially that deployable service which used to be part of SOA, kind of like a system, but it's much more technical in terms of defining how you deploy it, how you manage, and we're talking about deployment in container using Dockers, Kubernetes, OpenShift, all those things. They help really to contain and prevent your service to grow into a monolith. You have technical constraints already built in. And in most cases, it's just the same regular service, as you know, if you have been involved with SOA projects. So you know, access microservices through the pact, through the known API, but microservices collaborate in a decentralized fashion, which is in most cases true, but not always true. And definitely it's not the whole truth. And I'm going to mention it shortly. So if you just compare side by side, that's where people get confused. I understand that you might have been already converted and you understand what the problems are, but some people are still struggling in conceptualizing. So what is different between SOA based service and microservice? A critical piece here is that the domain-driven design comes into play. How you define your microservice. So that's one of the constraints where essentially contains your code from kind of expanding and becoming really grow unrestrained. Bounded context, it's the nouns and verbs that have been defined through the ubiquitous language, which make cohesive kind of a cluster and make sense to be deployed as a service. I'm not going to spend much time on it, but essentially you already have some I would say constraint the that context in which you would create your service. And microservices sometimes deliver purely utility functionality, whereas SOA services, they were most of business type of thing. So there is a question. So what is microservices architecture? Microservices architecture is SOA. I'll just come up with something which is unorthodox. Just don't hold me responsible. I just want to make it kind of clear for people to understand. It's essentially service-oriented architecture using microservices. So that's kind of a very politically incorrect way to say, but that's what I guess technically it is. Where microservices, essentially they're services, but they're very narrow in scope, and usually they require you to adopt certain ways of deploying those services and manage them. Okay, hopefully I was able to answer your question. So ESB, again, it's another derogatory term that people just try to avoid, as if, again, in our kind of world, even our technical world, IT world, people become some sort of, they adopt this attitude as if we have to be politically correct. Don't mention ESB, don't mention SOA. We just forget about what happened, I don't know, like 5-7 years ago. Now we are in this new kind of bright and brave world of microservices. It's not like this, because ESB in one way or another was a very critical piece of delivering very important mission critical projects with using SOA. And now, whenever you see that MSA abbreviation, it's just a way to say it's microservices architecture. Essentially, you can think about MSA as some kind of a distributed service bus. And there was a term coined by at ThoughtWorks, I guess Martin Fowler, or like some other folks from consulting of that, from the consulting wing of that organization. They coined this term, kind of a smart ends and dump pipes. Essentially, it's we're talking about an ESB. It's distributed. Dump pipes about messaging system, some sort of messaging middleware, where a system just doesn't care as long as the message is published and it's configured to produce to expose this message for consumption, whether through point-to-point communication or through pub-sub, it would be consumed. Right? That's the dump part. And smarts is moved to the endpoints of the system where microservices essentially they take on the role of what USB used to do. So ESB is still there. You can see its ears, you can smell it, and there would be an example where actually I will just show exactly that we still have ESB, we still have SOA. It's just a matter of to pay tribute to all those new things, pay to the old things, and just move on. A very good, kind of a quite chatty, verbose slide, but I guess those people who have been looking for some of the prescriptive recipes, they would find it useful. So you will have the area of the architecture and whether and the choice that microservices architecture take with respect to some of the attributes or aspects and rationale behind it. So I'm not going to go through all of those things. I guess the critical piece is that there is much more technical depth in microservices architecture compared to SOAs. And that depth actually helps to prevent the proliferation of monoliths to make your applications more robust, more performant. For example, the binary payload encoding using protobuf or Avro. Nobody actually was talking about this during the SOA days, and specifically requiring that your services are stateless. That's the first choice. And again, it helps with scalability, it helps with fault tolerance, resilience, communication, very similar to what SOA did. It's not very prescriptive. You can use any of those things available to you, but Microservices, they place, I guess, more emphasis on asynchronous communication. And there are a whole suite of patterns that are related to that. And so that's kind of shows that the technical side of things really take care of that abstract side of things. And the traditional 4+1 architectural view of your system becomes kind of a, it's the same, it just makes sense, but what happens is that certain parts become linear, particularly like development view, but that statement is not really, again, it's true, but it's not totally true, because, for example, the physical view becomes much more kind of complex. That's where you need to start thinking about how you actually materialize those services. You need to have containers, you need to have some sort of infrastructure in place to do that. And process view becomes more complex because you need to manage, I guess, that interaction between services. The orchestration part becomes really critical, right? Logical view pretty much stays the same. What can make your architecture brittle if you use microservices? Right off the bat, distributed transactions. So that's where monolith applications, where if the transactional semantics is very important for you, if that way of mission critical type of financial type of applications, they all care about consistency and transactions, where you can roll them back using interface, commit, or similar mechanisms. And now with distributed nature of your architecture, you need to start thinking about distributed transactions. So I will mention a pattern for that. So Saga. And sometimes if you go from that SOA side of things, you might not think upfront about fault tolerance, failure propagation, monitoring, because everything was just one log file, which was kind of as a repository of all the messages coming from different components of the same monolithic application. Now it's kind of becoming different. Automation is absolutely indispensable. It's mandatory in order to successfully implement those architecture. And not testing, not designing for test and failure. So I guess that's where things probably would be interesting. We're talking about commonly used patterns. And by the way, in the course that we have developed, we give enough information for every pattern so that you would be prepared to intelligently implement it. So backends for front end, so macro UI pattern is very critical. There would be a slide which actually I will walk you through using that. The facade, so API gateway, that's where essentially you introduce that single point of entry into your system. It sort of becomes that ESB endpoint. For your service mesh, there'll be more details here. Command query responsibility segregation. It's just a way to take your CRUD operations, create, read, update, and delete into two components, read and create, update, delete into a separate process. You have two processes which have their own specific purposes, specialization, and it's a way to create scalable, maintainable way of interfacing. Saga is a way to manage distributed transactions. In essence, you just have a way to compensate for any failed. If you have a failed transaction, you would roll back manually using the Saga infrastructure. There are systems that support Saga to roll back those transactions. For example, you do a trip booking. You want to book a hotel, buy air tickets, and rent a car. If any of those, and you do it sequentially, and if any of those gets failed, you have to compensate the previous successful transactions by issuing the cancellation. transaction. Event sourcing is a very popular in high throughput systems. Anti-corruption layer comes from the domain-driven design bulkhead. It's a way to minimize the impact of a failing system. There are multiple mechanisms for doing so. For example, using local database or using load balancer. It's just not very, it's kind of just a concept to prevent propagation of the failure. And circuit breaker is another resiliency pattern where you have a proxy for your service, which essentially for the happy path passes on request from the client to the service, and then it would return the response back. If something happens with the backend service, which is fronted by the circuit breaker, this term is borrowed from the electrical engineering. Essentially, it starts throwing exception to the client without forcing the client to wait for the response. So moving on, very important questions that you have to answer before you build your microservices architecture is centralized or decentralized client access. And the common idea about microservices is that they operate in a decentralized manner. And it's not always true because centralized access through the facade or API gateway is also possible. That decentralized access is supported by the service mesh pattern, where every service, A, B, C in our case, which gets deployed on its own host, usually there is affinity one-to-one, one service, one host. It might be physical machine, a VM, or a container, like a Docker container. And you would have a component of your infrastructure which would be responsible for all those quality of service that you need, like resiliency, which is based on timeouts, circuit breaker pattern, service discovery, routing, and possibly logging, monitoring. So your service essentially not communicating directly with other services. That service comes and all the communication goes through that service mesh. It's kind of a sidecar type of thing. You have it deployed as some sort of a binary, and it's co-hosted on the same machine. And service mesh communicates with other service mesh components, which in turn provide the response to the service in question. So you can use any of the open source unknown protocols for that matter. So that's a slide that I wanted to mention to you from backends for front ends, or to front ends to backends pattern with macro UI. Fictitious banking site where you have the banking website implemented using microservices. So you have loosely coupled services for paying bills, opening account, and what's not. And all those services are available for consumption by clients through the data aggregation layer, which essentially is a facade or API gateway. So that's the way to centralize access to those web services. It's not decentralized because in this case, we really want to enforce all the required services for security, for logging, monitoring, and what's not. And then the services essentially, they would use some sort of a shared services and probably some sort of a storage solution. But the point here is that current monolithic applications, they already have all those things. Like you would have probably a jar file responsible for supporting money transfer, paying bills, and what's not. And if you have this architecture already in place, it would be much easier to break up your monolith, your kind of ER file into separate WAR files deployed as a service, or using maybe Spring Boot or any other kind of inversion of control systems where you can provision an HTTPS endpoint through just deploying one jar file. Okay, so microservices interconnectivity is critical because that's where things really become very, they really slow down the communication inside your service and making your solution not very responsive to clients' requests. A very critical piece here is to use asynchronous communication patterns. And now, instead of using some of the proprietary, very expensive solutions from some very well-established vendors, you can use lightweight messaging systems, for example, those which use AMQP, which is a wire-level protocol for interoperability. And some of the systems that are very popular with folks is RabbitMQ, for example, a system which runs on top of Erlang infrastructure, which uses actor model, essentially very robust, very production-ready system. And that messaging system becomes, as I mentioned earlier, the dumb pipes. Essentially, the smarts are not here. The system has been just wired to deliver messages to a particular queue or publish to a particular topic. Okay. And for front end, there are a number of things that you can do to implement the reactive type of programming style using non-blocking remote calls such as Ajax, WebSockets, and promises. JavaScript has become so powerful that now you can create rich internet applications and delegate everything to the sync server, which just becomes a bunch of RESTful endpoints. Data exchange interoperability consideration is also very important. I guess that slide that listed all the areas and choices and rationale we mentioned in passing those like interchange formats such as Google Protocol buffers, Avro. The point here is those are binary RPC encodings which allow different programming languages communicate to each other. So it's no longer the requirement that you are exclusively .NET shop using C# or VB.NET or Java shop. You can have a microservice written in the Go language or Python, Java, Ruby, and in order to establish that kind of a level field for every service to communicate to any other service, you should use those interchange formats, which essentially would require some client code, and all those languages they implement those formats natively. Very fast, very efficient, and in many cases you can, I guess, avoid using HTTP-based services like REST or SOAP. You can go through TCP/IP, raw TCP/IP, a very efficient way to provide communication channels between services. So how would you implement microservices? With microservices, you have a number of options that are frameworks, and that's the best way to fast track your creation. Your development cycle becomes much shorter. And currently, a very popular way is to use systems which allow you to embed HTTP server, such as Jetty, maybe Undercloud, Tomcat. Again, it's the Java side of things. I believe .NET has the same similar systems. So essentially, you have your jar file. Instead of you don't need a war file or year file. You have a jar file which just provisions that embedded HTTP endpoint on demand in the public static void main method, and it becomes a fully fully enabled HTTP server. You don't need JSP compiler because that dynamic generation of pages, JSP, JSPX, has been factored out to the rich client applications. We're not going to talk about this. We do cover those aspects in the class. You can also embed databases. Java is very good in this department, so you can have a number of systems. For example, Apache Derby is part of JDK that you get when you download it from Oracle. It looks like, I guess, you can skip using external application servers that we know are great. They have lots of capabilities, but in most cases, you no longer need those. That's the overall trend. So in the Java world, people use Drop Wizard, Spring Boot, more systems coming on board. If you are not in Java and you don't want to deal with Microsoft technologies, a very popular choice is Node.js as a platform for building and running microservices. It has its, I guess, pros and cons. It's up to you. Don't just get driven by those hypes that exist. So take a longer look, and sometimes you might find yourself better off to use maybe just uses Java Spark, not Apache Spark, Java Spark project, which essentially emulates the same kind of logic for creating services. So Node.js with Express can allow you to build very efficiently RESTful endpoint services. So managing microservices, that's where things become really very difficult. That's where that accidental complexity becomes a reality. You need to start thinking about how you would manage, how would you bring into order configuration management, deployment, a variety of life cycles, transparent service versioning, and what's not. And for that, definitely automation is a critical factor, and adopting container and container orchestration solutions so that you can use Kubernetes, OpenShift to drive your Docker container fleet in a more intelligent way. Designing for failure, it's a good design practice, and it particularly valid in the context of using microservices, right? And you can support it by using the stateless design of your applications and generally in order to be successful, you need to know what's going to happen if a particular part of your system goes down. You just need to have a way to test it, so that design for failure comes hand in hand with testing for failure. So designing for test and test-driven development for your code, for your services, where you can test them in isolation from others by creating mock-up services, stubs, emulators, and what's not. Okay, so our offering, that's why I mentioned this course that we developed. It's a 2-day, very hands-on. In terms of, I guess it's not so much about deploying RESTful services. I guess it's not the focus, but how to actually look at your monolithic application, how to find the suitable, I guess, ways, how to define microservices and how to deal with data, was it event sourcing or local database. All those labs, they kind of pen and paper for the most part. There are 3 labs for that. Okay, so that's it from me. It will be time for me to take any questions, if there is any. Please put your question into the Q&A pane. the question is, can the service mesh be looked at as being an orchestrator across multiple services? I don't think so, Leo. It would be more of a kind of dumb. It has some smarts, but essentially it's a dumb, dumb pipe. It's a sidecar. It's kind of an attachment to your motorcycle. The service essentially uses it to communicate with other services. It cannot really orchestrate saying, okay, I cannot really talk to this service. So in case of a failure of service C, I have a backup service. So it doesn't have this logic. But I guess you can always add it. You can add another layer on top of service mesh. So that orchestration, so you kind of got me going. So you can have this orchestration layer on top of service mesh. So service mesh is essentially it's a dumb component. Okay, Leo. Okay, you're welcome. Can you give a real example comparing SOA to microservices? Maybe the bank example. Yeah, I guess I tried that, and maybe I didn't sound quite convincing. For example, that online banking site can be implemented as a regular ER file. So that ER file would contain multiple WAR files, right? Web archive, it's a Java way to create those zip files, which will be deployed on an application server. ER file, it's enterprise application archive, which is the biggest Uber kind of module which you would deploy on an application server, which might contain lots of dependencies, jar files, lots of WAR files, and kind of things honky-dory, you deploy it. But the problem is that if a particular thread in a particular WAR file, let's say you do a bill payment and something just goes just rogue, it fails. It creates an infinite loop, and it will bring down the whole ER file. It will bring down the whole application, your online banking. If you have a problem because everything gets deployed in a single contiguous heap, you give it like 8 gig, fine. But then through fragmentation or any other things, at a certain point in time, you have enough of heap size available for deployment, but the heap is fragmented because of, I don't know, maybe DOM type of processing, document object model. Sometimes it kind of can create those situations, and you are stuck. You have lots of memory, but it's fragmented, and your application is out of water. Okay, so SOA would definitely be present because you would have a clear-cut separation between paid bill functionality, open account, transaction history, transfer, and what's not. Okay, SOA would be there, but it would be implemented in terms of jar file, and they would be bundled together. Those services might use WSDL file, WSDL file, to expose those services for doing bill payments, and that's fine. And you might even go to the extent where you'd have the bill payment as a SOAP service standing there or deployed as a separate machine. But there is no, I guess, physical constraints, as I was trying to kind of get across, contain that proliferation. And with microservices, I guess, you start thinking in terms of how I would create build service such that it would not be dependent on anything else. You can test it in isolation. And it would be running on a single machine, on a single host, where I need to start thinking how I would scale it. Scaling would require like you provision a new instance. That instance would get using DHCP, a new IP address. How would I make the system, that gateway, API gateway, know that there is another service with that IP address that you should kind of discover and use for doing bill payments? SOA didn't really think about those details. It was just, I don't know, if we want to scale it, we would just deploy it manually. With microservices, you would need to start thinking about automated deployment, where you would have some sort of a threshold, and where you see that at the API gateway that the number of calls exceed a particular threshold. Let's say like TPS is, I don't know, 10 transactions per second, that would be an indication that you should provision additional service. How would you do this? You need to start thinking about status architecture so that you externalize your state into external storage, and so that a new service or failed service would be supplemented or replaced so that that session would be picked up. Your client request coming in with some sort of a cookie carrying or maybe a HTTP header, and how would you pick up the state from the failed service? SAA didn't care. They just were talking about, okay, we're talking about business capabilities aligned with services without really going into technical details. It was more about selling those consulting frontier, where lots of people who learned about SOAP, they were kind of eager to get contracts and start building those very fancy applications without kind of the more complex, the higher rates they could command. So that's kind of my point. So Adam, hopefully I was able to answer your question. So the question is, what is the best way to secure MSA? The best way, Paul, the way I see it, through centralized access. So that would be the way. If you do decentralized, you would need to start thinking about security at every juncture of the road, which is kind of not a good way. In case of this type of architecture, you centralize access. And all the calls, essentially, you create a security perimeter around your services. Right, so that's it's kind of a bastion type of thing. So that's probably the way to see it. And security and resiliency is achieved by deploying a service, having this affinity one-to-one. You deploy a service on a container. It's much easier to monitor what happens at a very kind of basic deployment level. You can have lots of things. You can capture through the log files. You can analyze any fishy type of activity. Hopefully I was able to answer. Okay, you're welcome. What are your recommendations around governance and change management planning of microservices in a large IT shop with hundreds of applications, not just managing them with, say, Docker? Governance is a big thing, right? And the larger organizations, the most verbose and detailed governance and policies should be. I guess one of the things would be that your services should be pluggable. I'm not sure how best incorporate it, but generally there should be a very prescriptive policy saying that you need whoever is responsible to create a service which can kind of exist in kind of a vacuum. Everything just fails, but your bill payment would survive and it would continue to carry out useful service. Usually you can do this through some sort of a feature enablement, disablement, where you would have a way to, at runtime, to disable certain services so that your clients would see a message saying this service is currently not available, we're experiencing technical difficulties, please try again later. But the bill payment would be kind of still standing. It would be delivering service. So your policies, your governance should be built around enforcing those rules. And that is part and parcel of designing for failure or creating your applications such that they're testable. As you see, those policies and governance, they were very high level. And now you have to be very low level. You need to go to the nitty gritty. You mentioned that not managing them with, say, Docker. Yeah, you can deploy it on a host. That's fine. But I guess there should be ways for you to capture the kind of zeitgeist of your application. At every point in time, you should have a way to interrogate the health of your system. You can use Splunk, you can use, I guess, Datadog or any other systems, which would allow you to run a query saying, well, what is the situation? How many transactions have been issued? How many I guess 404 did I get, or 500 errors. And a mandatory implementation of, for example, circuit breaker, or like circuit breaker, as I mentioned, is critical for creating that kind of a boundary between anti-corruption layer, if you will, between, and you can repurpose circuit breaker to do lots of other useful things, to prevent the backend service from getting overloaded, and lots of things. As long as you have a proxy, and that proxy, of course, will kind of give you lots of overhead, lots of maybe headaches, but if you have the service in place, if you do it right, it might help you on a number of fronts. So I cannot really answer, John. I understand it's a big question, right? And we understand this, but I guess you need to start looking at the technical side of things and reflect them in your policies. So the data layer. So the question is, where is the data layer fit into this architecture? It's behind those shared services. The common, I guess, rule, and that's where I guess people get stumbled. And again, it was proclaimed a while back. I believe it was ThoughtWorks again, Martin Fowler and the gang. They talked about the local database so that you can kind of create that unit of deployment, and people just blindingly deploy it. And I don't see that it helps very much, because you create lots of inconsistencies. Your data become not consistent. You have difficulties in replicating data. So essentially, your data layer should be part of your shared services, right? So it should be kind of that front, that aggregation layer. And the backend definitely should not be just one monolithic, again, I'm using this term, database. RDBMS, it might be very powerful, definitely no kind of a vertically scalable. Everything's kind of cool, but that's not the way to go. You should have a way to embrace NoSQL where they have that scalability sharding in place, and they maintain that high availability property of services right out of the box. It can be MongoDB, it can be, I don't know, it might be Cassandra or something else. Robust, they support multiple clients, or you can have some sort of, if you have your deployment in the cloud, you can use any of the managed service, and that's the way to go. For cloud native applications, you would have something like, I don't know, DynamoDB on AWS. It's extremely robust. You cannot break it. They wouldn't let you. And it would be like local. You would have a table. They would probably provision it as close to your service as possible. So lots of options. And I guess I'm running out of time, guys. I really appreciate the questions. SSL, critical part of the solution. Yes, SSL, you need to, I guess, come up with some sort of HTTPS connection pool so that SSL handshake could be, I guess, Nginx, you can use Nginx to do that reverse proxy. Yes, so the question is SSL. I believe other folks are interested as well. SSL is critical, but SSL will slow down 20% easy. It'll just shave off your performance. SSL is critical if you don't trust systems, if you cross boundaries, if you do peer to kind of a business-to-business type, yes. But at least you can create some sort of, as I said, HTTPS connection pool. And that Nginx, just do research on the internet. They have some solutions. Okay, guys, that's all the time. Thank you for attending. We just scratched the surface of that thing. But again, be realistic. Don't get infatuated with another fad or microservices that would help us. Start slowly, adopt it, and kind of do proof of concept, and slowly build robust, solid practice, and kind of nurture a new culture of DevOps and all that stuff. Okay, thank you very much. That's all I've got for today. Okay, all the best. Bye-bye.